Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is lesson 9 in my Starting Off in C++ series, where we finally get to the thing that puts the plus plus in C++, object-oriented programming. Why would we do object-oriented programming? We've just spent all of these weeks learning how to write functions and do functional programming. Why would we want to change to object-oriented programming? The answer is objects bundle data and the functions that work on it in ways that are often very convenient for writing the big program that you're trying to write. Breaking your big program down into smaller objects, even if it's just one object, can make the main program logic much easier to write. Some examples might be an object might hold an employee's paycheck data and the function that calculates her pay. Or it might hold a physical object's size and location in space, and then functions that calculate its geometry, like its volume, or whether a particular point is inside or outside a sphere, or something like that. You might have a date-time structure. Remember, we've used date-time structures in C++. In regular C, you might have a date-time structure as an object that can actually calculate time differences between itself and another date-time, and or might be set up to output its date and time as a nicely formatted string. You might have a projectile object that simulates its own flight path. You remember, if you took my class, you remember doing the fly ball out of the park baseball object simulator. Imagine if you could program a baseball object that simulated its own flight path, and not only did the very simplistic calculation we did in that assignment, but maybe even took into account air resistance, drag, and the lift that the baseball gets from spinning as it flies through the air, and all of those things that we can't simulate as easily just writing a little equation. And finally, object-oriented programming has largely enabled programming of graphical interfaces. Graphical interface buttons need to know what to do when they are clicked. Okay, and that is largely made possible by object-oriented programming. Okay, so today's project is that first one that I mentioned on the previous slide, an employee paycheck. You know that each employee in an organization has certain data that affect how much they get paid each month. There's a monthly base salary. Of course, your salary obviously has some effect on what you get paid. But there's also a certain percent that's deducted for taxes, and that might have to do with how many dependents are in your family, or whether you're married or not, or these things are different depending on different people. And then there's a monthly deduction for benefits. You might get employee-sponsored insurance. You might get employee-sponsored retirement plans. I even had worked at a company once that deducted my parking permit from my monthly paycheck. Made my paycheck a little smaller, but at least it was done before taxes, so I got that had to pay that much less tax. Okay. So we can write a class of employee objects that keeps track of these three things: salary, tax rate, and benefits, and then calculates its own pay at the end of the month. To help in designing objects, there is a specific kind of diagram called the universal modeling language, or uniform modeling language, that's been designed for graphically representing object-oriented programs. Now, our program only has one object type in it, one class, so this diagram is going to be really simple. It's going to have one box that's divided into three parts. The top of the box tells us the name of the object, class, employee. The next one gives us the data members, also known as member variables, also known as properties in proper object-oriented terminology. So we're going to have a name, which will be a string. We're going to have a monthly salary, a tax rate, and benefit deductions. Okay. And then in the bottom third of the diagram, we see all of the member functions, also known as methods in object-oriented terminology. There's going to be a constructor that takes the four main pieces of data and constructs a new employee. There are going to be setters for tax rate and deductions because an employee's tax rate might change or their benefit deductions might change. We're going to assume that their name is not going to change, and for salary, we're going to assume that nobody's just going to arbitrarily change their salary. Instead, they're going to give the person a raise every now and then. And then we're going to have getters. We don't need to get back the raw salary, the tax rate, or the benefit deductions. What we need to get back is the paycheck amount. So we're going to have a getter for get name, and we're going to have a getter for get paycheck amount. Hopefully you understand the logic there. If not, hopefully it'll become clear as we go through this. Okay. To define a class in C++, you write class name. As with structs, we tend to capitalize the name of a class, and we tend to use what's called camel case, where every new word gets a capital letter that looks like the humps on a camel. You're going to have a private section of your class or object in which you're going to put all of the member variables, because we want to keep our member data private and only access it through public getter and setter functions. And then we're going to have a public section in which we put the constructor or constructors. You can have multiple constructors, and all of the member functions as well. This is a little different if you're coming to C++ from, say, Java or C#. This is a little bit different because in Java and C#, each individual line in the class description is either private or public. In C++, you have a whole private section and a whole public section. Okay, and then after the class definition, you come back and you define your member functions. And you're going to use the scope operator here, the colon. We've seen this before in standard : CN, standard : Cout. That's a namespace use of it. This is a class member use of the scope operator. It tells C++ that the function you're about to define is a member of a class. How do we use a class object? Well, we can declare one as simply class name myObject, or we can say class name myObject and in parentheses put all the parameters needed for the constructor. Okay, some objects require parameters to construct them. Some objects work either way. The string object that we've worked with before, you can say string myString, or you can say string myString open parentheses and put an initial value for the string in the parentheses. You can also say myObject equals class name parens. You can call the constructor explicitly to construct a new object and put a copy of that in myObject. You can do myObject.set field name 1. We don't usually put myObject.field name 1 equals something because usually field name 1 is private. But set field name 1, that function would be public. We can see out myObject.get field name 2. Again, field name 2 is private, but the get function is public. We can make a vector of class name. We can push back myObject onto that vector. And we can use myVector at 0 dot get field name 1 and send that to cout. Okay, so as usual, as we set up our program, we're going to pound include some IOStream and IOManip and then vector, because we're going to be making a vector of employees. Now, in an object-oriented program, you're going to often find that most of your programming is spent defining your classes and objects, and that the actual program at the end is very, very short. So you're going to see that here. We're going to spend the next 5 minutes on defining the class, and then the final program will go bang, bang, bang. So class employee starts with a private section, and we start by defining the data members. String name, double monthly salary, double tax rate, double benefit deductions. These are all private, so they're all going to be set by the constructor, and then they can be modified by setter functions, but they're not going to be modified directly by the program. Now, define the member functions. These will be public. We have the first one here is called a constructor. Note that it has the same name as the class, employee, and that it has no return type, not even void. Okay, it's not even a void function. It's just it's a special kind of function called a constructor. And you'll note that it's got one parameter for each variable that we need to set up in our employee class. Then we have a couple of setter functions, and you'll notice that property setters can often be defined in a single line of code. So you don't have to prototype these and then define them later on in your program. You can just write this off as a one-liner. The same is true for property getters. Oftentimes it's even just 2 lines of, not just one line of code, but it's 2 words of code, return name, and that's the whole function. Other functions like get paycheck amount are going to be longer when we write them. We know they're going to be longer when we write them, so we just prototype them here, end them with a semicolon, and that semicolon promises C++ that we're going to define the function later on. You'll note here we've done that with the constructor, and we've done that with get paycheck amount. Now, the constructor is very easy to write because it's just assigning values to all of our member variables, but we have to make sure we initialize all of them. Okay, so we have 4 member variables: name, monthly salary, tax rate, benefit deductions, and you'll notice that we have 4 lines of code for that. 1, 2, 3, 4. You'll notice the use of the scope operator, the colon, that tells C++ this function belongs to one of our classes. And you'll notice the use of the this pointer that helps C++ determine which side of the equation is the member variable, it's the one that this points to, and which side is the parameter of the function that's been sent here by the main program to set up our function. Now finally, we get to write the program logic that this whole object-oriented program has been driving at. Okay, it's the get paycheck amount. We're going to determine tax as monthly salary times tax rate divided by 100. Okay, it's a very simple way to calculate tax, but for these purposes that will do. And then we're going to return a monthly salary minus our tax minus our benefit deductions. Okay, so as I said, we spent the last 5 minutes or so setting up the class, the object, defining the object. Now all we have to do is make a couple of objects and use them. To make the objects, we could declare a variable employee, employee 1, Jim Camp 50/50, etc. But it's possible in C++ to just call the class name like a function, to call you're explicitly calling the constructor to construct a new object here, and we're pushing that back into the employees vector. So Jim Camp makes $5,050 a month. He gets a 10% tax rate because he doesn't have any dependents, and he pays $450 in monthly benefits because he only pays health insurance for himself. Liz Mons, on the other hand, makes less because, statistically, women make 80 to 90 cents for every dollar that a man makes, right? Sad but true. Hopefully not true forever. And then she gets 5% tax rate because she's a mother of, say, a couple of kids, and she gets $600 in benefit deductions because she's a mother of a couple of kids. She has to provide them health insurance too. So once we figure out what numbers we need to populate, we just create these employees and push them back into our employees vector. We can now set up a quick loop to print the paycheck amounts, and this is where object-oriented programming really pays off. We just do a little for loop for auto employee and employees, cout employee.getName, employee.getPaycheckAmount. Now, with inflation being so high lately, we ought to really give our employees a raise. So fortunately, we built this into our objects. So we can cout giving a 5% raise, and then for each employee and employees, we call employee.giveAraise and give them a 5.0 raise. Note here that to make this work, I called the employee by reference, or I pulled the employee out of the employees vector by reference. Otherwise, we'd be making a copy of the employee and giving it a raise, and the original employee object would never get the raise they so richly deserve. Okay, and then we print, we do another for auto employee and employees and print employee.getName and employee.getPaycheckAmount. And here, this is what the output looks like. Jim Camp gets paid $4,095 a month. Liz Mons gets paid $34.77 a month. We give them a 5% raise, and you can see that the dollar amounts did in fact go up, though with taxes and benefits, it's not exactly a 5% change in the paycheck. May actually be slightly more than a 5% change in the paycheck. Okay. So what we've learned today: how to define a class or object type, how to call the class constructor as a function to populate a vector. That's a useful skill. How to use objects to calculate values for you, get paycheck amount, how to use objects to modify themselves, okay, give raise, okay. So those are two very useful properties of objects, that they can calculate their own values and they can even modify themselves. Okay, now I'll have a project for you to work on back on the Blackboard site, and look forward to seeing you get your feet wet in object-oriented programming. Until next time, good luck and happy programming.